Good evening, friends. Let us continue with our time speed, distance problems. Okay, the next one. The average speed of a train in the onward journey is 25% more than that in the return journey. Onward journey is actually faster than the return journey for this train. The train halts for 1 hour on reaching the destination. The total time taken for the complete to and fro journey is 17 hours, covering a distance of 800 kilometers. So 1 hour it is waiting at the destination. That means what is the travel time? Travel time is 17 minus 1 hours, which is 16 hours. So forward travel time plus return travel time is equal to 16 hours. Okay. And he's saying speed of forward journey is actually 25% more than the speed of return journey. So S forward is equal to 1.25 into S return. Let S be the speed. Speed of return is SR. Speed of forward will be 1.25 SR. Now what is saying? They're covering a distance of 800 kilometers. That means forward is 400, return is another 400. What is the time taken? Time taken forward plus time taken return is equal to 16 hours, right? What is time forward? It is distance forward by speed forward. Distance forward, which is 400 by speed forward. Speed forward is 1.25 times of speed return, right? We'll directly put it like this. Plus distance of return by speed of return. This is equal to 16. We just substituted T forward, we just modified this equation to this format. T forward is forward distance, which is 400 by 1.25 SR, which is speed of return, which is equal to speed of forward. Right. We wrote it like this. Then we simplified only one variable, speed of return journey. There is no other variable. When we simplify this, 400 will take it out. 400 by speed of return will take it out. Then 1 by 1.25 plus 1, which becomes 9 by 5 is equal to 16. Then that becomes, if we simplify this further, speed of return will become 45 kilometers per hour. Right. What does that mean? Speed of forward, which is 25% more than speed of return. That means 1.25 into 45, which is 56.25. So the speed of train in the forward journey, in the onward journey is 56.25 kilometers per hour. This is an easy problem. Only thing that we need to know is to write this equation, and be able to create this equation. Next one. A car travels the first one third of a certain distance with a speed of 10 kilometers per hour. Next one third distance with a speed of 20 kilometers per hour. And the last one third distance with a speed of 60 kilometers per hour. The average speed of the car for the whole journey. What is the average speed? Average speed is total distance covered by total time that is covered. Let us assume the first one third is x, second one third is another x, third one third is another x. Right. What is the time taken for first one third? It will be x by 10. Right. Speed is 10 and distance is x by 10. Second one third time is x by 20 because speed is 20 and distance is still x only. Third one third is x by 60. Speed is 60, distance is same. So third one is much faster. X by 60 is much this part is much faster. That means x by 60, the time would be much slower. X by 60 is less than x by 20 is less than x by 10, right? So this time would be much smaller, right? Now total distance by total time. Total distance is 3x by total time is x by 10 plus x by 20 plus x by 60. We'll take x common, x into 1 by 10 plus 1 by 20 plus 1 by 60, which is equal to 1 by 6. Right. So 3x by 1 by 6, x will get cancelled out. This becomes 18 kilometers per hour. Right. Please note, don't get confused. 3 by 6, 3 by 6 versus 3 by 1 by 6. 1 by 3 by 1 by 6 is equal to 3 into 6 by 1. Okay. So 3 by 6 versus 3 by 1 by 6, right? Similarly, 3 by 2 by, sorry, if you have to do like this, 3 by 2 by 1 by 2, then this is equal to 3 by 2 into 2 by 1. Okay, right. So you can understand it like this. 3 byte is what? 1.5, right? 1.5. 1 byte is what? 0.5. zero point 0.5 three times will become 1.5, right? That is like this. It is like this. Don't get confused when doing these fractions. Right? 3 by 2 is equal to 1.5. 1 by 2 is equal to another zero point 0.5. 1.5 is equal to 3. Okay. Similarly, 3 by 1 by 6 means 3 into 6 by 1. Please understand this. If you have any doubts, please tell me. Okay, this is an easy problem. What we need to do is average speed is equal to total distance by total time. Total distance is 3x because the distance one third to second one third and third one third, these are all same distances. Right, distances are same. The speeds have changed, that's why times will change. Okay, next one. A man can reach a certain place in 30 hours. If he reduces his speed by 1/15th, he goes 10 kilometers less in that time. This is a good problem. Find his speed. A man can reach a certain place in 30 hours. Okay, so let's assume the distance equal to speed into time, right? Distance by speed equal to 30 hours. 30 hours, let's assume the man's speed is some s. Okay, so the total distance is covering is distance equal to 30 into s. Right. Now, if his speed is reduced by 115, then what does it mean? His new speed will be 1 minus 1 by 15. Right. 1 by 1 minus 1 by 15 into s. That will be the new speed. Right. So, so what is the time? The time is 30 hours, right? With the reduced speed, that is 1 minus 1 by 15, 15 into s speed, and still 30 hours, he is able to go 10 kilometers less. That means new distance is d minus 10. See, in 30 hours, if it is a normal speed, he would have gone d, 30 into s. But with a reduced speed, he is going d minus 10. What is the reduced speed? 1 minus 1 by 15 into s. That is the reduced speed. And time is still same. In the same 30 hours, he is reaching 10 kilometers less. That is d minus 10. If you simplify this, 1 minus 1 by 15, which is 14 by 15 s into 30 is equal to d minus 10. That means 10 you bring it this side. 14 by 15 s into 30 plus 10 is equal to d. If you simplify this, then 28s, this one if you simplify this, 28s plus 10 is equal to d, right? This is d. Now we know d is also 30s, right? We also know d equal to 30s, right? We'll use that 30s here. That means 2s is equal to 10 and s is equal to 5 kilometers per hour, right? 2s equal to 10, s is equal to 5 kilometers per hour. See, this is also an easy problem. What he's saying is, man can reach a certain place in 30 hours. That means the time he is traveling is 30 hours, and we don't know what is his speed. Okay, we don't know. He's taking 30 hours, but we don't know what is the speed. But he's saying if the speed is reduced with a lesser speed, he will still travel the same 30 hours and still reaches 10 kilometers less. Right. So that means you are able to calculate what is his speed. Right. Speed is 5 kilometers per hour. And then what is the total distance he is traveling? 30 into this 5. 150 kilometers he is traveling. Right. 150 kilometers is the total distance he is traveling. Right. Please understand these problems. All these problems, we need to be able to write this kind of equations. Whatever the information that is given, we have to find in most of these problems. There will be two combination of speed, distance, and time, and one combination of speed, distance, and time, another combination of speed, distance, and time. And most cases, either time will be equal, or distance will be equal, or speed will be equal. Then you should be able to write the two equations independently and combine them basis on whatever that is common. In this case, the time is same in this case. Let's do more exercises. Starting from his house, one day a student walks at a speed of 2.5 kilometers per hour and reaches his school 6 minutes late. 6 minutes late. Next day, he increases his speed by 1 kilometer per hour and reaches the school 6 minutes early. How far is the school from his house? See, here also there are two combinations of speed and time. Right, there are actually two combinations. The distance from house and school will always remain same. Whether he walks fast, he walks slow, then the time, how long does it take, that only will change, right? But the distance between his school and home will always remain same, irrespective of whatever speed he's walking. If he's walking faster, he will reach it. He'll reach it faster. If he's walking slower, he will reach it slower. So any combination of for every speed, there will be some time. There will be some corresponding time. Even if you walk with 10 kilometers per hour, there will be some time in which you will reach the school. If you walk with 50 kilometers per hour, then also, if you run with 50 kilometers per hour, then also you will reach in some time. Right? For every speed, there will be some time as long as the speed is greater than zero. Right? If the speed is zero, if you are not moving, then you will never reach. As long as you are moving, even if you are moving 1 centimeter per hour, you will still reach your destination. Right? So, so here let's see, here it is also given some two combinations. What is the first combination? First combination is 2.5 kilometers per hour. Right, that means 5 by 2 kilometers per hour. That is the speed. At this speed, he is reaching his school 6 minutes late. So that is t plus x. Let's assume t is the time which which on at which he will reach exactly as per the time. Right. Now, as in, let's now at some speed, he will reach the school on time. We don't know what is that speed. Probably that speed might be 10 kilometers per hour or 5 kilometers per hour. We don't know. But at some speed, he will definitely reach the school on time, right? That is always possible, right? If you walk slower, then you will reach late. If you walk faster, you will reach early. But there will always be some speed at which you will reach the school on time. Okay, right? There will always be at that speed. There will always be some time which on by which you will reach the school on time. Okay, let that time be t. Right, let the time. The time may be 10 minutes or 20 minutes, 1 hour, whatever it is. Okay, now this speed 5 by 2 into the t plus 6 minutes. Ideally, we should write t plus 6 by 60. Right, because it is speed is in kilometers per hour, time also should be in terms of hours. Let's say t is also in minutes, t plus 6 also in minutes, then t plus 6 by 60 we have to write. But anyway, the right side also we have to write by 60. We can anyway cancel that 60 and 60. So I have directly written as t plus 6. Please note this. Don't assume that I am writing kilometers per hour here and in terms of minutes here. It is also should be in hours, but 60 and 60 will get cancelled. So you don't need to worry about that. Okay, so at the speed of 5 by 2 kilometers, he is taking 6 minutes higher, right? Into t plus 6. At the speed of one more kilometer per hour, that is 5 by 2 plus 1, which is 7 by 2. He is reaching 6 minutes early. Right. That means t minus 6 is taking 6 minutes less. That is t minus 6. Whatever distance is traveling in t minus x at 7 by 2 kilometers per hour is equal to distance is traveling in t plus 6 minutes at a speed of 5 by 2. Right. These two will be equal. These two will be equal to the regular speed, whatever it is, for to reach the school on time. That will be equal to some s into some t. Some s into some t. We don't know what is the t, we don't know what is that s. But doesn't matter. But that is the ideal time and ideal speed, right? To be on time, right? Now let's take these two equations only. Then we'll just simplify. By 2 will anyway cancel. 5t plus 30 is equal to 70 minus 42. To simplify this, 30 plus 42 is 72. 2t is equal to 72. T equal to 36. So t is in minutes, right? T is in minutes. T is equal to 36 minutes, right? So what does that mean? What is the total distance? Total distance, we can substitute this t in this also or in this also, right? We cannot substitute here because this s we don't know, right? Because we know both of these s's, we'll directly put either here or here. Let's choose to put here 5 by 2 into t plus 6. T is 36, 36 plus 6 is 42. 5 by 2 into 42. But here we have to put in terms of hours, because this is in minutes, right? This speed is in kilometers per hour. So kilometers per hour into number of hours, that is 42 by 60. Number of hours is 42 minutes is 42 by 60 hours, right? 5 by 2 into 42 by 60. This becomes 7 by 4 kilometers, right? Which is 1 3 by 4 kilometers. Okay, next one. Robert is traveling on his cycle and has calculated to reach point A at 2 p.m. If he travels at 10 kilometers per hour, he will reach there at 12 noon. So at 2 p.m. he's calculated at 2 p.m. if he travels at 10 kilometers per hour. 2 p.m. If he's traveling 10 kilometers per hour, he'll reach at 2 p.m. He will reach at there at 12 noon if he travels at 15 kilometers per hour. At what speed he must travel to reach A at 1 p.m. Right. So that means the speed must be somewhere between 10 and 15. Right. At 10 kilometers, let's say 1 p.m. is the ideal time. At 2 p.m. at 10 kilometers is too late, and at 15 kilometers per hour is too early. Right. His speed must be somewhere between 10 and 15 to reach there at 1 p.m. Right. So now how long does it take? We don't know. Right. Whether the total is taking 4 hours, 8 hours, 10 hours, that we don't know. Just that we know that he is reaching little early or little late. Okay, from his place to reach that point B. What is the total time? Whether it is 4 hours or whether it is 5 hours, that we don't know. We only know that if he is traveling at this rate at 10 kilometers per hour, he will reach in 2 p.m. And if he is traveling at 15 kilometers per hour, he will reach two hours early. Right? Doesn't matter. Doesn't matter. So what we will do, T1 S1. Let's say T1 is a time first time T1, that whatever it is, and S1 is equal to speed 1. Speed 1 is 10 kilometers per hour. And T is equal to T2 into S2. S2 is the speed of 15 kilometers per hour. At S1, at speed of 10 kilometers per hour, let's say, is taking some T1 hours. We don't know what is the T1. It could be 3 hours, it could be 5 hours, whatever. But at speed of 15, we know um, he's taking 2 more hours extra, because instead of 2 p.m. he's taking 12 noon. That means he's taking, so sorry, 2 p.m. he's taking actually 2 more hours extra. Right, that we know. Right, we don't know what is that, but what are those numbers? Right, so T1 at 10 kilometers per hour, he's taking 2 more hours than when he was traveling at 15 kilometers. If 15 kilometers per hour, the time is actually T2, then T1 would be T2 plus 2 hours, right? T1 is equal to T2 plus 2 hours, right? Now, we want a third time which is actually T2 plus 1 hour, right? At 12 noon, if it has to be 1 noon, 1 p.m., then it has to be T2 plus 1 hour. T2 plus 2 hours is actually 2 p.m. T2 plus 1 hour will be 1 p.m., right? So keep it like this. Now, let's substitute this. T1 into S1 is equal to T2 into S2. What is T1? T2 plus 2. T2 plus 2 into 20 is equal to T2 into 15. Let's simplify this further. 10 T1 plus 20 is equal to 15 T2. What does that mean? T2 is equal to 4. Wonderful. So, in reality, he's taking 4 hours in the faster case. Right? At 12 noon, he's reaching. That means he's starting at 8 o'clock and he's reaching at 12 o'clock. That is that 4 hours. Now, at the same time, if it is 4 hours, then T1 is equal to 6 hours. Right? T1 is equal to 6 hours. Right? But the total distance will always remain same. Right? T2 into 15. Right? It will always be, so T1 into S1 is equal to T2 into S2 equal to T3 into S3. Right? S3 we don't know. S3 we don't know. But T2 and S2 we know now. Right, T2 is up. His T2 is just figured out it is 4 kilometers. The time it taking. Right, so he's starting at 8 o'clock and he's reaching at 12 o'clock. So the time is 4 hours. And the speed also we know, which is 15 kilometers. So 4 into 15, 60 kilometers is what he has to travel. That also we figured out. Right, that is the 60. The 60 kilometers he has to travel out. He has to travel. Now he is taking 5 hours. In the case when he has to reach at 1 p.m., he's taking 5 hours. 60 kilometers in 5 hours. What does that mean? The speed should be 12 kilometers per hour, which is this. Right. So please understand, in all of these problems, you need to be able to write that most, in this case also, the distance is constant. Right. The distance can be written in multiple formats: T1 S1, T2 S2, 3 S3, whatever cases that were given. Right. We just need to write these equations correctly and then substitute one of them in the other to get this one. Right. So he's here in this case. We know he's traveling at 10 kilometers per hour, but when he started, we don't know. But he reached at 2 p.m. that we know. If he is traveling little faster, then he is reaching 2 hours early. That also we know. But we don't know in both the cases when at what point he has started. right? But doesn't matter. These two are sufficient. These two are sufficient because um, the distance is same. If the distance is someone else, then if the distance is about something else, then we cannot solve these equations. But in these equations, the beauty is the distance is constant. Robert is traveling and to reach point A. Same Robert and same source says same destination. Instead of Robert, if some other information was given, some Sham has to travel somewhere to somewhere, and we have to compare both the two. Those will not be possible. But in this case, the given information is sufficient. You need to be able to write these equations. Now, if a train runs at 40 kilometers per hour, it reaches its destination late by 11 minutes. But if it runs at 50 kilometers per hour, it is late by 5 minutes only. Right. So, what does that mean? The train has to run even faster, right? 40 kilometers, it is late by 11. 50 also, it is late by 11. That means the ideal time. If it has to reach in the time, then it has to run even faster. Right. But we don't need to know the distance here also. It probably this could be 55, it could be 65, we don't know, but doesn't matter. Now let's assume the time which it takes is t. T is the ideal time, which is not late. Okay. Now at t at some point of at some speed, it will not be late, right? Let us assume that speed be s and that time be t. Right. So the train it still has to travel the same destination, right? From whatever source, this destination, it still has to travel the same distance. Okay. That same distance, whether it travels at 40 kilometers, 80 kilometers, 50 kilometers, but still the distance is same. But at some speed, its time is exact. Its time it will reach without any late or without any early time. Right. Let that be t, and let that speed be s. That s into t is equal to that s into t, that is ideal speed, ideal time, is equal to, okay, that ideal speed. Now 40, if it has run at 40, it will take t plus 11. T plus 11. See, again here, t plus 11 by 60. Here also t plus 5 by 60, s into t, t by 60, if t is in minutes. But anyway, it is by 60, it will get cancelled. I have ignored that. Okay. So 40 kilometers taking t plus 11 minutes. And 50 kilometers, it is taking t plus 5 minutes only. So, but the distance will always be same. Distance 40 speed into these many minutes is equal to 50 speed into these many minutes into I is equal to ideal speed into t minutes. Okay, let's take first two equations. 40t plus 440 is equal to 50t plus 250. Right. So then 10t is equal to 440 minus 250, which is equal to 190. That means t is equal to 19 minutes. So if it travels at the right speed, then it will take 19 minutes. You can always calculate what is the right speed also, right? We can do this 40t, 40 into 19 plus 440 is equal to right speed into 19, right? You can simplify this. What is the right speed? 40 into 19 plus 440. This is 1200 by 19. This means right speed is somewhere around 63.1 kilometers per hour. 40 into 19 is what? 40 into 19 is 760, right? This is 760 plus 440, right? So 800 plus 400, which is 1200. 1200 by 19, which is equal to 63.1. Okay. So so now we also have realized, right? 40 kilometers also it was late, 50 kilometers also it was late. That means the speed should be somewhat higher. What is that speed? We have calculated that speed should be 63 kilometers. Right. So 40 into t plus 1. So basically what it is happening, 40 kilometers, 40 kilometers and t plus 11. T is what? 19 plus 11 is equal to 30 minutes. This is time. This is speed. This is equal to 50 kilometers into 19 plus 5, 24. This is equal to 63.1 kilometers into 19 minutes. Okay. So these are the various combinations. This is the correct combination that we want. We want the train to run at 63.1 kilometers per hour and reach in 19 minutes. Okay, whatever is the source and whatever is the destination. Okay, we can in fact actually calculate the distance also, right? 40 into 30 is the 1200. Sorry, 40 into zero point 0.5. 30 by 60, right? 40 into zero point 0.5. 20 kilometers is the distance, right? 63.1 into 19 by 60. That also will give you the same thing. Okay. So these are various combinations are possible, but the ideal combination is 63 kilometers, 63.1 kilometers per hour, and 19 minutes. And that is the ideal time. Yes. Now, a man covered a certain distance at some speed. We don't know what is the distance. We don't know what is the speed. Had he moved 3 kilometers per hour faster, he would have taken 40 minutes less. Okay. Had he moved, so the relation between earlier speed and current speed is given. A relation between earlier time and current time. Two different times. Earlier, the first kind of speed and first kind of time is also given. Second kind of first kind of time and second kind of time is also given. The distance is common. And if he had moved 2 kilometers slower, he would have taken 40 minutes more. Very good. Right. So S into T again. Right. S into T is the ideal time. Okay, 40 minutes more, 40 minutes less is saying, right? So what is the ideal time? There must be some ideal time and there must be some ideal speed. Let that be S into T. Now S into T is equal to, if he has moved 3 kilometers faster, that means speed would be S plus 3. And then the time would be T minus 40. Right? T minus 40. He would take 40 minutes less. So again, T minus 40 by 60. It should be T minus 40 by 60. I anyway cancelled the 60. So I did not even write. So is equal to S minus 2. If he has moved 2 kilometers per hour slower, that is S minus 2. It will take 40 minutes more, that is T plus 40. Okay, so this, let's simplify this. ST minus 40S plus 3T minus 120 is equal to ST plus 40S minus 2T minus 80. Right. This both of them will be equal to ST. So ST and ST will cancel. So this ST is equal to this. ST is equal to this also. Right. So we'll cancel ST and ST and for both the equations. So 120 becomes minus 40s plus 3t from this equation, from this and this. And similarly this and this will give 80 is equal to ST will get cancelled. Right. 80 is equal to 40s minus 2t. Right. Then this 1 and 2. If we add 1 and 2, what will become? 120 plus 80 is equal to 200. 40s will get cancelled. 3t minus 2t is equal to t. What is t? T is equal to 200 minutes. Okay. So t is equal to 200 minutes, and 200 minutes equal to how many hours? 3 hours 20 minutes. Right. 200 minutes equal to 3 hours 20 minutes. This is equal to 3 hours. Sorry, 3 1 by 3 hours. Right, 20 by 60 hours. 3 1 by 3. That is equal to 10 by 3 hours. Okay, this is the time. 10 by 3 hours is the time. 10 by 3 into, okay, so t equal to 200. If you substitute this 200 in one of these equations, right, in one of these equations, either this equation or this equation, then we will get s is equal to 12 kilometers per hour. Okay, so what is s? Speed is 12 kilometers per hour, and what is the time? What is the ideal time? Ideal speed is 12 kilometers per hour. Ideal time is 10 by 3 hours. So 10 by 3 hours into 12 kilometers per hour, we'll get 40 kilometers. 40 kilometers is the actual distance. Right? You understood this, right? Here we are given three combinations of S and T. Ideal time into ideal speed versus the two. The when he's faster, then what is it? When he's slower, what is it? This is the faster, higher speed. This is the slower speed. Then we equated both of this independently. This equal to this equal to this. Then then we solved both of them, and then we arrived at what is the ideal time. Ideal time here, because see t minus 40, t we did not convert into hours here. T minus 40 directly by 60 we are doing. So t is also in minutes. right? If t is in minutes, then we have to convert. T is 200 minutes equal to 3 1 by 3 hours, right? 10 by 3 hours. And then S also we calculated. S is equal to 12 kilometers per hour, right? So total distance is 40 kilometers. Next, a train can travel 50% faster than a car. Both start from point A at the same time and reach point B 75 kilometers away from A at the same time. The distance is given. Speed of train into time of train is equal to speed of car into time of car. On the way, however, the train lost about 12.5 minutes while stopping at the stations. The speed of the car is speed of train 50% that of car. So if car is 100, speed the train would be 150 kilometers per hour. Right. So if car is 50, then 1.5 into 50. Right. That is 75 kilometers per hour. If whatever it is. But we don't know what it is. Okay, let's assume speed of train ST is equal to speed of car into 1.5. Okay. Now, what is saying on the way, the train lost about 12.5 minutes while stopping at the station. 12.5 minutes, it is not traveling, right? But the car is still traveling. What means time of train is actually time of car minus 12.5 minutes, right? Because it is traveling 12.5 minutes lesser, right? Now, but the distance is same. Speed of train into time of train is equal to speed of car into time taken by the car, which is this. Which is this. What does that mean? Speed of train. Speed of train is 1.5 times of speed of car. Let's substitute like this. This is speed of train. Speed of train into what is the time of train? Time of train is time of car minus 12.5 minutes. Ideally, we have to do by 60 again because by 60 anyway gets cancelled. I did not write it. Okay, time of car minus 12.5 minutes is equal to speed of car into time of car. So S speed of car will get cancelled. Simplify this 1.5 into TC minus 1.5 into 12.5, which is equal to 18.75 is equal to time of car. That means time of car is equal to 37.5 minutes. Okay, so so far we did not even use the total distance, right? 35 kilometers. Now we will use it. Okay, speed of time, this both of them, this is area equal to 75 kilometers, right? The distance is same between both points, right? A and b, the distance is anyway 75. The car is traveling for 37.5 minutes, right? So that means how many hours? 37.5 by 60 hours. The distance is 75 kilometers. Now what does that mean? Speed of car will be 75 kilometers by time of car, which is equal to 37.5 minutes or 37.5 by 60 hours. This becomes 120 kilometers per hour, right? So 35 30, so this equals to 75 into 60 by 37.5. 37.5 goes 2 times in 75. 2 into 60 is equal to 120 kilometers per hour. Right, this is also an easy problem. You just need to write this equation properly. Speed of the distance is same, so that means speed of train into time of train is equal to speed of car into time of car. If you are getting confused with this notation, speed of train is equal to 1.5 into speed of car, you can directly use x and y. X equal to 1.5y, where x is speed of train, y is speed of car, whichever is convenience. Okay, and instead of TC and TT, you can say P and Q, whichever is convenient for you. Okay, if you're writing subscripts, you're getting confused unnecessarily. You can write it whichever way you want, whichever is convenient. You can always choose your variables. I'm not, I'll not suggest anything. Whatever is convenient for you, those variables you can use because everyone is used to use, will have comfort in some kind of variables. Some people use PQ, some people use XY, like that, right? Some people might use subscripts, whatever. So whatever is your convenience, use that. But I suggest, what my suggestion is, whichever you are using, you be consistent so that throughout the time, you will not get confused with your variables. So for example, speed, you denote it by s, let's say, then continue that. Some people denote speed with velocity, v. Okay, whichever it is, if you are consistent, then that's easier for you. Next one, excluding stoppages, the speed of a bus is 54 kilometers per hour, and including stoppages, It is 45 kilometers per hour. How many minutes does the bus stop per hour? Very good. So this is a very good problem. So all these problems, what I suggest, first you try it yourself. Only then look into the solution. You take a pause, videos, then read the question and then try to do it yourself. And then if you are not getting, then continue with the video. That is one option. The best option is that. Otherwise, what I suggest, if you go through this video, then at least once the solution is discussed, then again pause it and then do it yourself again so that you will remember. But important thing is you should do it. Only when you do it, your hand will remember, your mind will remember. That is very important. If I do it, I will remember. But if you do it, you will remember. Right? The important thing is you should remember. So you should do it. All mathematics, all exercises, you should always do it yourself. If I am doing 50 questions, you should be doing 200 questions. Okay, next. Excluding stoppages, the speed of bus is 54 kilometers. Including stoppages, it is 45 kilometers per hour. Okay, we don't know what is the stoppage, how much time it is stopping. Okay, doesn't matter. Okay, so what? Let's assume without stoppages, it takes time t. Okay, we don't know what is the distance also. Okay, so but let's assume at the ideal time, without stoppages, the distance is something. And what is the distance? That 54 kilometers per hour into that time. Okay, this time, this t is without stoppages. This is equal to 45 into t plus x. X is the time for stoppages. Okay, x is the time for stoppages, right? What does it mean? 90 is equal to 45x. Right, 90 is equal to, so 54t minus 45t is equal to 45x. What does that mean? X is equal to 9 by 45t. That means x is equal to 1 by 5t. So the speeds, because of the variation in the speeds, we are able to calculate x, the stoppages, in terms of t. Obviously, we should be able to calculate in terms of t only. Right. It depends a lot. It depends on what is the t. Right. So, for example, otherwise, x cannot be anything, no? X is always should always be fraction of t. Then only the speed will manage. So, for example, in this case, if t is 1 hour, in this case, if t is 1 hour, then what will be x? 1 by 5 of 1 hour, which is equal to 12 minutes. Then the speed will be maintained. If what for 1 hour, if he waits for 12 minutes, then it will be maintained. Then the average will still become 45. Okay, without speed, if it was 54. If it is 2 hours, then it can be 24. Right. Similarly, if the time is 50 minutes, then 1 by 5 of 15 minutes, like the waiting time can be 10 minutes. It depends on what is your total duration, right? So otherwise, if it is not fraction of total duration, what will happen if let's say you are expecting x to be some fixed number, x to be from some, let's say, 10 minutes or whatsoever, then irrespective of the time, even if the total distance is 10 hours, then also if it is 10 minutes, if total distance is 1 hour, then also it will be 10 minutes. It doesn't make sense, right? So that's why x is always a fraction of time. If the speed has to be maintained, then within the time of 1 hour, you will take this much break. Within the time of 2 hours, you will take so much percentage of breaks. Right. So here in this case, we don't need to know what is the distance. But but if he's taking, what does that mean? If he's taking without breaks, he will take 54 minutes. 54, let's say the T is 1 hour. If T is 1 hour, that what does it mean? The bus will travel 54 kilometers. Right. If the T is 1 hour, then bus is traveling 54 into 1, which is 54 kilometers per hour. Now, now he's taking 1 hour. How much break he will take? He'll take 12 minutes break. So that means he'll travel for 48, 48 48 minutes only, right? So you'll travel for 48 minutes only. If 1 hour, if 60 minutes he travels, will without breaks, he will reach 54 kilometers. If 48 plus 12 minutes breaks, sorry, So for each 1 hour, it will wait for 12 minutes, right? So 1 hour it travels, 12 minutes it has to wait. So what does that mean? Total travel is 72 minutes, right? Total travel is 72 minutes. But in reality, the bus is moving for 60 minutes only. So total distance is 60 minutes. In 60 minutes, anyway, if it without stops, it is traveling 54 kilometers. So total distance is 54, right? 54 distance by time. 54 by 72. So distance by time, right? Distance by time. What is the average speed? Distance by time. Distance by 72 minutes is equal to 54 by 72 by 60 hours is equal to 54 into 60 by 72, which is equal to 45 kmph, kilometers per hour, which is what that is given, right? So for every 60 minutes, it will wait for 12 minutes. So effective time will become 72 minutes. But in reality, the distance is still 54 only. It is not 48 plus 12, it is actually 60 plus 12, right? In reality, the distance is 54 kilometers only. But it took 72 minutes to reach the same distance of 54 kilometers with breaks, right? So now 72 minutes is equal to 72 by 60 hours, right? So then that means 54 kilometers it would take. Sorry, so if it is taken 72 minutes for 54 kilometers, then the speed becomes 54 by 72 minutes. 72 minutes is equal to 54 by 72 by 60 hours is equal to 45 kilometers per hour, right? Hope you understood these problems. Please be careful. In all of these cases, in most of these cases, distance is equal to distance. You should be able to write the distance in two different forms. S1T1 is equal to S2T2 equal to S3T3 equal to ST, whatever, like this. Right? In most of these cases, there will be some ideal time and some ideal speed. We should be able to spot it and write the remaining equations around that and make those equations equal to S into T and then solve them. These are all those easy problems. Let's pick up more problems in the next session. Thank you guys. All the best. Bye bye. If you have any problems, please comment and I will pick them also. Any doubts, please comment. I will pick them. Thank you.